In a global industry where anything can happen, where mistakes cost much more than dollars, we bring you expertise from around the world to ensure that everyone goes home safe every day. The internationally acclaimed Oil and Gas HSE podcast starts now with your host, Russell Stewart.
Hey everybody, thanks for tuning in to another episode of the OGGN HSE podcast. If you appreciate this podcast, and we get a lot of really nice comments and likes on LinkedIn and reviews on iTunes, we really do appreciate that. But please reach out and thank our sponsor, Endress & Hauser. Endress & Hauser is a global leader in measurement instrumentation services and solutions for industrial process engineering. They provide process solutions for flow measurement, level, pressure, temperature, analytics, and much more, optimizing processes and efficiency, safety, and environmental impact. They serve many industries across the globe, including a focus in oil and gas. Endress & Hauser, the people for process automation. Okay, today, hopefully you listened to last week's podcast, because today is part 2, and it was my pleasure to introduce last week a company called Bead Environmental. And Bead provides, as we discussed last week, a tremendous amount of services in the environmental area, and especially as it now relates to ESG and that sort of thing. And their specialty is probably drilling waste management. We had a slight introduction into that in last week's podcast, but that's what we're going to focus on specifically today. I want to welcome back to the show Barry Simpson and Adrian Longley. Guys, thanks for coming back on.
Yeah, thank you, Russell.
Well, let's jump right into it. Let's talk about drilling waste management and how we're doing a much better job now of not being that dirty old oil company.
Okay, Russell, that's fair enough. So I'll give you a lead in here and I'll discuss how I see drilling waste management, how I've seen it best done in Europe, Middle East, Africa sort of area. So I guess the easiest way to do this is just basically to take it from the top and go through the different steps that I see drilling waste management deals with. So when the mud obviously comes out of the wellbore after it's been drilled, it's full of drill cuttings, and you've got mud and you've got drill cuttings which come gushing out of the top of the well. The first thing that happens, obviously, is it hits the solids control equipment, which to me is integral to drilling waste management. Because if your solids control equipment doesn't work properly or isn't efficient, you will end up producing an awful lot of volume of waste, which then needs to be handled by your drilling waste management process. So you imagine it comes over your shale shakers. Your shale shakers are correctly set. They're working properly. They've got the proper shaker screens on them. And you get the mud is separated out from the solids. So the solids fall off the shale shakers, and either by gravity or by some other method, they are basically in a pile waiting to be treated. In the best circumstances in the world, they go into a tank or into a skip, and then they're there. You can haul them off, and we will move on to that in the next step. The fluids goes back around into the mud system and is in the reuse stage. So therefore, you're reusing and recycling those fluids. Now, if I come back to and obviously the fluids will also be treated by centrifuge, so you get more solids coming out of the centrifuge, which come and are deposited in a tank or a skip for further treatment. Now, depending on if you're using water-based or oil-based muds, this is your first step to enhance drilling waste management. If you're using water-based cuttings, you could try to discharge those cuttings off your first shakers onto what's known as a drying shaker, where again you're trying to recover a little bit more of the fluid back into the mud system, and what you get discharging off the drying shaker is the driest solids that you can. So it's the driest, it's the least amount, and you're using the maximum amount of recovery. And at that point, you've got water-based cuttings, which are pretty much ready to be taken away, to be disposed of. So at that point, you look at it and you say, well, what do I need to do to dispose of this? Can I put it into a landfill? Can I use it in some sort of construction process? Sometimes you can give it off to cement kilns where they will burn it, or sometimes you can get it put into some sort of facility, some sort of process where it's basically recycled and reused. But most of the time, what happens is it's then hauled off and it goes to some sort of landfill. And at that point, you need to understand what you need to do in order to get it accepted by landfill. It'll need to meet some sort of moisture content. It'll need to meet some sort of salt content. It'll need to meet some sort of hydrocarbon content. Hopefully it's not contaminated. If it meets all of these criteria, you can dispose of it. And that's pretty much a straightforward route for your water-based cuttings. Now I go
Okay,
back.
so let me just stop right there before we go to oil-based cuttings, and you'll have to explain to everybody, to a lot of folks anyway, what the difference is between water and oil-based, and we'll talk about that in just a second. But when you say it has to meet certain criteria for disposal into the landfill, and then here in a few minutes we're going to talk about what happens when it doesn't meet that criteria. But I mean, for the most part, of course, one of the things you said as far as drilling waste management goes, the very first step is to minimize the amount of waste that you have to manage in the first place. But when you get down to that final stage, these water-based cuttings, are they contaminated? Is it bad?
So what you do, obviously, is before you start drilling, you plan your waste management procedure. You find out in advance what you need to meet in order to have a solution for all of your different waste streams. For example, if you know that your landfill pit, say, for example, in Central Europe, landfill won't allow salt in the cuttings. Therefore, you go all the way back to your design process and you tell your drilling fluids company that if you're going to use water-based mud, you can't have salt, you can't have potassium chloride in the mud. So then they will do a product replacement, such as some sort of nitrate, or they'll find some way of using a glycol or something like that so that they don't have to use salt. So it's a bit reverse in that you find out what you need to have in order to dispose of it, and then you work backwards to make sure that what you're doing up front will give you the residue that you can get rid of.
Okay, all right. So now we go to oil-based. What's the difference between oil-based and water-based?
Right. So water-based mud, as the name suggests, is water and solids. So you have water as your base fluid, and in that you put in polymers to thicken the water, and then you have your various chemicals which clever mud engineers put in to make sure that you can viscosify your mud and that you can carry the solids out of the well, and it's got enough density to make sure you don't run into any problems. Now, oil-based
keep
mud,
the hole intact and all that.
And keep the hole intact and all of that. Now, oil-based mud is you have oil, which is your main phase of the mud. And in that oil, you put water. The water mixes with the oil and you get an emulsion. So you've got water droplets within oil. And then into that emulsion, you mix all of your chemicals that you need to keep the wellbore in good shape and your weighting agents. And basically, it's a very, very good mud for drilling, which is why everyone uses it. It helps people to drill faster. It helps people to drill better. And basically, that's why everyone uses it. But what we see from our side is that because it's oil, what comes out,
the main component in the oil is diesel, right?
Not all the time. Diesel
okay.
In some places, and in others, in order to be more environmentally friendly, it's replaced with a variety of synthetic oils.
Of synthetics, okay, all right.
Which are cleaner in that they have a better profile. When you do a chemical test on them, you see that they have a cleaner carbon chain. And basically what that means is if you come to treat, it's easier for any of the various processes that we'll talk about to break down the oil, and so become better.
Oil and water don't mix, so you have to, and you use the word, you have to put something in there which emulsifies these two things.
Yes, you do.
So that they blend together.
Yes, so they blend together and stick together and stay as a mud. Otherwise, you get the unpleasant time when your mud splits into oil and water and solids, and then the company man is not very happy.
And the mud engineer gets fired.
And the mud engineer gets run off. So yes, so we go all the way back to the cuttings are bouncing over your shale shakers, and they fall off the shale shakers, and they are covered in oil. And obviously, oil is something that you don't want to be getting anywhere. So there are a number of processes that you can do there. You know, you can run the drying shaker, or you can run what's known as a vertical cuttings dryer, which is very, very prevalent in the Gulf of Mexico. Because if you take your oil-based cuttings, run it through a cuttings dryer, you will get down to less than 6.9% of oil on your cuttings, and then by Gulf of Mexico standards, you can discharge overboard. This also happens on land because it's a good way of recovering the mud, which goes back into the mud system, and reducing the volume, which you then need to haul off. And then that volume can leave the site, and if it's not been discharged, as in the Gulf, it can leave the site and basically be put into landfill in an awful lot of places. Now, that's one stage. In some other parts of the world, using a vertical dryer, that getting your cuttings down to 6.9% oil content is not good enough for final discharge. In the UK, for example, North Sea waters, you have to get down to less than 1% oil content on your cuttings. And the only way that can be done is to use what's known as a thermal process, where the cuttings are heated up in a process, and what comes out is powder with less than 1% oil content, and then that can be discharged overboard. So that's another process for the oil content.
Okay, now you're talking offshore here.
That's both offshore and onshore.
Okay.
It can be done in both places.
Now, this thermal process doesn't happen on the rig, does it?
It can happen on the rig, and it does happen on the rig. There's a lot of the new generation rigs now which have the thermal units built into the rig infrastructure. In the earlier days, going back to 2001, 2002, when this was first being tested in the North Sea, they would send out a small unit and it would sit on the deck, and you would process on the deck and discharge directly overboard. That still happens now on rigs which have short-term contracts. But in a lot of the newer, especially the drill ships, they build them directly into the superstructure when the rig is being built.
So would you say, as far as we're talking offshore, is that the most common technology used?
Oh, no, the most common technology used is still what's known as ship-to-shore. That's basically when your cuttings are just discharged from your solids control equipment. They're put into containers on the deck of the rig, whether that be by gravity or some other process like a vacuum unit. And then all of these containers are lifted onto a ship and are sent to shore. And once they get to shore, they're generally taken to a thermal unit like the one I've just described, set onshore and treated there.
Okay. But one way or the other, the actual final resting place for these cuttings is through a thermal process most of the time?
A lot of the time in the countries which have stronger regulations and have that pretty much set in stone, where they say, if you can get it down to less than 1% offshore, you can discharge it, or you can bring it to shore and then you can treat it and then it can go to landfill. Some other countries which don't have such strong drilling waste management rules allow you to basically do nothing at all. Other countries which you can try and do what's known as bioremediation of the cuttings. This is now back onto land, where you would just take your cuttings and spread it around on the ground and try and treat it with microbes and bugs and try and turn it into a soil that can be left on the ground.
And you can actually do that, right?
You can. There's some very good technologies, but this has been worked on for a number of years. It was very prevalent in Colombia. It was quite a big thing in Africa and in parts of Asia as well. And the best I ever saw was in New Zealand, where they actually put in instead of salt, they put nitrate into the mud, and then the cuttings were treated by worms. And basically they turned the cuttings into a very high-grade fertilizer.
Oh, wow. Now, there's other ways they've bioremediated those cuttings and recycled them with like road material, for example. Is that right?
Generally, what you do, if it's allowed, which I have seen in a number of places, is they do take cuttings and they try to treat them with something like cement or lime. And what this is a stabilization process. The idea being that if you treat the cuttings with additional product, you can try to form a matrix to lock the contaminants inside this matrix so that it becomes more stable and hopefully won't allow the nasties to leach out. But it's not very well trusted in a lot of places. So there's a lot of information both for and against it. Some places allow it, some places don't allow it. There've been examples where this has happened and they've used it in various construction processes, and then they've ended up having to dig it all up and dispose of it in another way.
and redo it, huh?
Yeah, and redo it.
If you're turning it into fertilizer, I mean,
Yes,
you would think that's a no-brainer.
that's a great process, but it was a very one-off project, and it was extremely successful because they planned it so well.
So why isn't that common today?
That's a good question. I mean, I don't see it very often. I've seen it a couple of times in Europe, but this is all because the legislation deemed that you couldn't get rid of.
I think some of the reasons there is, that kind of bioremediation processes dependent on the local climate, the volumes of waste that you're generating and this kind of stuff. So if you've got a lot of drilling activity going on in a cold climate, it's probably not a suitable area for doing that kind of stuff. Right, Adrian?
That's true enough. That is true enough. But, it can be done. It's just time consuming. It's space consuming. And it's only really done if there's no other simpler route for disposal. Specifically if you can't dispose of waste with a certain chloride content, for example.
See, I would think the concept of recycling would, contribute to everybody's sustainability equation or whatever.
Well, you never know. This might all come back, and become popular again. So that's sort of a couple of the routes for cuttings. The other one that we haven't really touched on is cuttings reinjection, which I particularly like. I think it's a great disposal method. I mean, cuttings reinjection can be done on the rig, or it can be done off-site as well. It's basically where you gather all of your waste, your fluids and your liquids, and basically you pump it down a well, which has been fractured, has been carefully modeled by some much cleverer people than me, geomechanical modelers, to make sure that the waste is safely bound up down, a few kilometers down, and is then trapped.
Yeah, let's talk about that because, of course, you said the F word on the podcast. You said fracking. So they're putting all this bad stuff down there, and now you're talking about taking all this contaminated drilling stuff and sticking it down there, and you're just going to completely pollute our entire water system down there, right?
No, that's not what we're going to do. That's exactly why you use geomechanical modeling, to make sure that whatever you put does not come anywhere near the aquifer. It's usually so far below the aquifer. What they do is they find a well which has a suitable formation that you can deposit the cuttings and the waste, and then above that you make sure there is an extremely thick barrier which is impermeable, so that any of this waste cannot go up and reach the surface.
And not only that, every well has what's called surface casing, so that protects the water table in itself.
Yes, that's right.
The bottom line is, we create a lot of waste when we drill a well, but for the most part, and especially you guys have been in this thing for, 20, 30 years and that sort of thing, the industry has made great inroads into protecting the environment, right?
Absolutely. I mean, we do everything we can to protect the environment. There are so many options to what you can do to deal with the drilling waste, and we do.
There you go. And that's the point. Obviously, this is the Oil and Gas Global Network. Obviously, we're huge proponents of oil and gas. Somehow or another, we have to get to the point, it seems to me, like in this country and around the world, that it's not us versus them. And, we don't want dirty water and dirty air and dirty land and, contaminated foods or drink contaminated water any more than anybody else does. And not only are we not contaminating the environment, we're actually leading the way and helping to clean it up.
Yeah, I fully agree. And there's some tremendous technologies coming out which will clean up all of the wastes, and more importantly, will be efficient with regards to cost, will be efficient with regards to energy. And coming back to the point we made on the last podcast, the driver going forward, as well as environmental, is now carbon footprint and ESG.
Yeah, and we talked about that last week, and these things are all positive. We can all work together, and companies like Beat Environmental are helping to spearhead that effort, and that's why on this podcast, we want to showcase companies like Beat Environmental. Last week, if someone happens to be listening who didn't listen to the show last week, you guys have a plethora of services and all kinds of expertise around the world that can all be found on your website. Barry and Adrian, I really appreciate you guys coming on. Hopefully people are listening to this and it's coming off without a hitch, which it generally does with our production people who put these podcasts together. But nobody will know some of the technological challenges we had in getting this podcast together. So again, I want to thank you guys both for coming on the show. As we said, we'll be sure to include your LinkedIn contact information in the show notes so anyone listening can contact you directly. I want to thank everyone again for listening and remind you that this podcast would not be possible if it were not for our sponsor, Anderson Hauser. Please tell them thank you for sponsoring the show by going to our OGGN Anderson Hauser website, which you can find a link to in the show notes, and register for our monthly giveaway there. Also follow us on LinkedIn and Twitter. And that contact info you can find in the show notes. Finally, you can find in the show notes my LinkedIn contact info where you can message me. Please let me know what you're enjoying about the show and suggestions for content you might like to hear. Also, if you're looking for a speaker for a conference or meeting, you can contact me about having one of the speakers from our OGGN Speakers Bureau, including Mark LaCour, to come and speak. Please tune in again next week for another episode of Anderson Hauser's Oil and Gas HSE podcast, a production of the Oil and Gas Global Network. Anderson Hauser is your reliable U.S.-based and international partner for measurement instrumentation services and solutions. We are your people for process automation. Please leave us a review on iTunes, like us on LinkedIn, and use all of your social networking to tell your friends about us. And now here's Savannah. We'll see you next time.
Hey everybody, it's Savannah from OGGN, and here are the events on deck for July 2021. This month we have 5 events, but if you'd like the full list, you can click the link in the show notes to sign up for our events newsletter. We send it out every month, and it includes more info about the events I talk about here. We even include events that occur 2 months ahead of time, so if you're always interested in staying in the loop about oil and gas events, make sure to check that out. This month, OGGN will be hosting our monthly happy hour at the Cannon in Houston, Texas on July 29th. Our June happy hour was a hit, so if you weren't there for the June one, we hope to see you there this month at our July happy hour. At this event, you'll be able to meet some of OGGN's hosts and network with other oil and gas industry professionals, all while enjoying great food and drinks. Don't forget that it's on July 29th. Other than OGGN's events, we have 2 in-person and 2 online events. First up, we have our 2 in-person events. The first one being the Doug, Permian, and Eagle Ford Conference at the Fort Worth Convention Center from July 12th to July 14th. And the next in-person event is the SPE International Data Science Convention at the Norris Convention Center in Houston, Texas on July 8th. Next, we have our 2 online events. The first being a Cognite webinar titled From Buzzwords to Boardrooms, What Energy Leaders Really Think About the Transition Towards True Sustainability, and that's on July 8th from 11:30 to 12:30. And lastly, we have the US-Africa Energy Forum, which is online on July 12th. If you have any questions about these events or any of our shows, make sure to reach out to me through my email in the show notes. That's all for July. I hope you guys have a great month, and thanks for tuning in.
Tune in next week for another engaging episode of the Oil and Gas HSE podcast, a production of the Oil and Gas Global Network. Learn more at oggn.com.